Hello everyone. I welcome you all to the second part of introduction of the video EC8453 linear integrator circuits. And this is Divya. Let's get into the video now. What we're going to see now is general classification of ICs. Generally, ICs are classified into two types. They are monolithic circuits and hybrid circuits. In monolithic circuits, every component of your IC, that is your resistors, capacitors and your transistors, each and every component will be fabricated internally with a common substrate, whereas in hybrid circuits we'll be connecting the components onto a common substrate and then we will interconnect them by using wire bonds. Here in hybrid circuits, individual components will be connected, whereas in monolithic circuit, if component will be created on a common substrate. Monolithic circuits are further classified into two types. They are bipolar circuits, unipolar circuits. Bipolar circuits, obviously it is made with bipolar junction transistor, whereas unipolar circuits are made by using field effect transistors. Bipolar circuits are also further classified into two types. They are on the basis of the isolation that is done between the junction. If it is PN junction isolation, and then it can be of dielectric isolation. Similarly, unipolar circuits are also further classified into two types. They are MOSFET circuit and JFET circuit. This is the general classifications of your IC. Then what we are going to see now is the technology that we are using, the grade of technology that has been increased when the years passes. During the year of 1960 to 65, the first invention of your IC, that is small scale integration technology, has been introduced, in which a single IC chip contains a minimum 3 to maximum 30 number of logic gates, and if in the form of transistors, we will be having up to 100 transistors per chip. This is small scale integration. This came into line after the invention of transistor. And then years passed by. After 5 years, during the period 1965 to 1970, we have medium scale integration technology, where we have 30 to 300 number of gates per chip or 100 to 1000 number of transistors per chip, which can we see 10% increase on your number of gates or transistors. 10 times increase. Then we have large scale integration technology. Again, we have 10 time increase of your gates or transistors that can be incorporated into a single IC. Then we have VLSI technology, very large scale integration technology, where we can incorporate or integrate more than 3000 gates onto a chip and up to 1 lakh transistors per chip. And then we have ultra large scale technology, where we can have more than 30,000 gates per chip or 10 power 6 to 10 power 7 number of transistors per chip. Then what we have is giant scale integration. What we are using now have more than 3 lakh number of gates per chip and more than 10 power 7 transistors per chip. This is giant scale integration technology. This is what we are using in our 5G technology. Then we are going to see the devices that is usually manufactured by using what technology, and your logic gates, your operational amplifier, all these basic components are manufactured by using small scale integration technology, where the number of devices will be 1 to 100, and your shift registers, filters will be manufactured by using MSI technology, medium scale integration technology, and up converters, analog to digital converters will be manufactured by using LSI, large scale integration technology. And then your memory cards, computer chips and signal processing chips will be manufactured by using very large scale technology, and ultra large scale technology is not used in India now. And we are seeing the most famous op-amp manufacturers, starting from Ablix, Cirrus Logic, Dialog Semiconductor, Fairchild, Maxim, Microchip Semiconductor. We have different manufacturers. What I have given you is a list of them, some of them. We have many more manufacturers of your operational amplifiers. What we are seeing is the top 10 operational amplifiers that is used worldwide. Out of the most commonly used op-amp is IC741. That is the subject of you for linear integrator circuit syllabus. And then we have many more ICs, LM324, 339, 3140. We have much more things. And IC747 is also one of the most commonly used IT. That is what we are going to see in your syllabus also. What we are seeing now is the syllabus of the subject AC8453 linear integrated circuits. In unit 1 we are having the basics of operational amplifier, how it is going to work, its characteristics, what is the internal components that is present in your op-amp, all those things we'll be having in unit 1. Unit 2 we are seeing applications of operational amplifier, what are the applications where we can use all those operational amplifiers. Unit 3 we are having the advanced applications of your op-amp, that is analog multiplier and its phase lock loop. Unit 4 how we are going to use it op-amp as analog digital converter and digital to analog converter. And unit 5 we are going to see how the op-amp is used as waveform generators and special function ICs by other than op-amp 741. This is the common syllabus of your EC745 8453 linear integrated circuits. In for triple E also we will be having most of the topics in common. Thank you all.